All right, so we're going to expand that last video just a little bit and talk about the same thing that we did for the power rule, and we're going to talk about what it means to distribute when you have quotients. Okay, so distributing, we know, can look like this, right? When we're talking about, right, a multiplication, right? But if we're talking about a power, sorry, let me move that down a little bit. It would be 3 times x, and 3 times negative 4 would give me 3x minus 12, right? But we looked at some other ones last time that were distributing a power to a power, right? And that means that this is doing this 3 times, right? So we have 2 times 3, which is 6. And then we have this is doing this one 3 times as well. So we have 3 times 3, which is 9. So we have, oops, this should be x, I'm sorry, x to the 6th and y to the 9th, right? Just like that, we're going to talk about what happens when you have a distributive rule applied to a division problem. Well, this is 2 to the 4th and 3 to the 4th. So that's 2 times 2 times 2 times 2, or 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3. So total I have 4 2's and I have 4 3's, right? So 2 to the 4th and 3 to the 4th is what I have. So this 4 gets given to the 2, but it also gets given on the bottom to the 3, right? It gets distributed to each part inside the parentheses. The rule really hasn't changed. It's just you're thinking of the parts a little bit differently. So let's look at this one. We can work either to the right or to the left. If we're working to the right, 3 times 3 times 3 times 3 times 3 times 3 means this was 3 to the 6th, right? And this on the bottom is going to be 5 to the 6th. Pretty easy, right? Well, what does that mean it came from? Well, the base was 3 to the 5th, and we're doing it 6 times, right? Essentially, what happened was that 6 got distributed to both parts of the problem. So let's look at the one beneath it, 8 to the 6th and 2 to the 6th. Where did that come from? Well, 8 was done 6 times over 2, which was done 6 times, right? And we can put those all in their own parentheses because they're all being multiplied by each other, or we could put a dot in between them, however we like. Okay, but essentially what this is saying is 8 over 2, which is the same thing as 4, so that really should be simplified. But 8, 8 over 2, right, is taken to the 6th power. All right, well, let's look at one that's got an extra little thing in it. So we're looking at 2 times x over 9 to the 3rd power. Well, that's 2x over 9, right? 2x over 9 and 2x over 9, right? We're multiplying that 3 times. So how many 2's do I have? Well, I have 2 times 2 times 2, which is 2 to the 3rd power. And how many x's do I have? X times x times x, which is x to the 3rd power. And how many 9's do I have? 9 times 9 times 9, which is 9 to the 3rd power. Okay, so we're talking about that. Now, if I were really doing this on a problem, I would probably go ahead and simplify and say 2 to the 3rd power is 8, right? And 9 to the 3rd power is going to give us 81, right? So we're going to have big numbers here and just do regular numbers here. But just for the purposes of showing what's happening, I'm leaving it like this. So let's look at this one. 3 to the 10th times a to the 10th, and then 12 to the 10th, b to the 10th. Okay, where could that have come from? Well, let's think backwards, right? Think about where that 10 came from. The 10 on these ones, or the 3 on these ones, was this, right? The 10 on this one is probably going to be our number outside the parentheses. So what was the things inside the parentheses? Well, I had 3, right? Because 3 got a 10, A got a 10, 12 got a 10, and B got a 10. So 12B, right? So essentially, this was 3A over 12B written 10 times. I don't necessarily want to do that, but I can, right? I could try to write it out 10 times. I only can really fit 6 here, and I would do a couple more, dot, 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 right? So 3A over 12B written 10 times. So again, when we just have variables, we don't know what the number is here, but we can think about that as being a distribution, right? So a to the n over b to the n power. Hopefully this is kind of making sense, right? So again, what do? We just distribute to each term. And in this case, it's the top and the bottom. Okay. So we distribute that exponent on the outside to each term inside. And these ones don't have any exponents on the inside, but if they did, we would be distributing and multiplying, just like we did with the power rule, okay? So one last thing before I end this video, because this is a really simple part, and I just want to kind of tack it on to the end here. Let's think about, we're going to expand what the quotient rule means, right? The quotient rule, what we learned was that if we have a to the m over a to the n, it's the same as a to the m minus n, right? Well, let's look at these examples. If I have 2 to the third and 2 to the third, well, then I've got 2, 2, 2, and I've got 2, 2, 2 on the bottom, right? 2 times 2 times 2, 2 times 2 times 2. Well, I cancel, I cancel, I cancel, I cancel, I cancel, and I cancel. Well, what's left? Well, nothing, right? Nothing's left. So what I really have is 2 to the 0 power. But what does that mean, 2 to the 0 power? Well, remember, if I had something like an x, right, and there's nothing in front of it, but these two x's cancel each other, there would still be a 1 or an invisible 1 left in front of them. So when I cancel all of these, I still do have a 1, which is why what I'm going to say in a second hopefully will make sense. When I cancel all my terms like this, I'm going to end up with the answer to anything to the 0 power, right? Anything to the 0 power, the answer should be 1. Okay, so 2 to the 0 power, the answer is 1. Let's look at the next one, 5 to the 7th and 5 to the 7th. Well, I've got 5 7 times. That's 1, 2, 3, 4, 5, 6, 7. Good. And then again, right? Cancel, 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 cancel. Each one on top cancels with one on bottom. I'm left with nothing, but there is still a coefficient in front, which is 1. So 5 to the 0 power is also going to be equal to 1. So what's my answer left over? It's just 1. Same thing's going to be true here, right? Remember, let's think about what's actually happening here. 7, when we did our dividing rule, we subtracted. What's 7 minus 7? 0. So our power ends up being 0. What's 3 minus 3? 0. So our power ends up being 0. But anything to the 0 power is just the 1 that's left over when you take away all those 2's or you take away all those 5's because you canceled them. So 20 minus 20, right, again, I'm not going to write it out, but 20 minus 20 is going to give you 0. So x to the 0 power, the answer is going to be 1, because when you cancel all those 20 and all those 20, you're going to be left with a single 1 left in front. So anything to the 0 power should equal 1. And this is a rule that's very, hopefully, simple to remember, okay? And hopefully I've kind of demonstrated why that is true. This is 1 that's in front of any term or any part of your equation is left over when everything else gets canceled. So again, you have practice on the back. Take a shot at it.